All right, so today we're continuing to talk about proving triangles are congruent. Um, Today we're going to be using two different postulates, ASA and AAS. These stand for angle side angle and angle side. So the game plan for today is to be able to say I can use the ASA postulate to test for congruence, and I can use the AAS theorem to test for congruence. All right, so our one new vocab word for today says included side, so the side between two given angles. This should sound very familiar because we had an included angle back when we talked about SAS, which was side angle side. So the included side is just pretty much, I don't want to say the opposite, but very similar to an included angle. So it's just that side between two angles that we know are congruent, where it's sandwiched in there. All right. So, ASA, angle, side, angle. So this says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay. So essentially what this is saying is if we have two angles that are the same, like we do in this case, because we have E. Let's try to get that circle somewhere close. So we have angle E and angle B. Then we have angle A. In red this time, please. Thank you very much. We have angle A, angle D. And then in between them, we have this line that is the same in both of them. So anytime we have that kind of pattern where we have an angle, then we have a side, then we have an angle that are congruent and corresponding in both triangles, then we, of course, have congruent triangles. Lovely stuff. Okay, so this is our first real kind of proof problem that we've dealt with in this chapter, and I feel like it's probably a good thing that we kind of start to practice these. So anyway, what they tell us here is, let me make sure I'm in the right spot. Yes. So they tell us that L is the midpoint of WE and WR is congruent to ED. So first things first, what we know right off the bat, we know L is the midpoint of WE, and we know WR is parallel to ED. So right away, first thing I want to do, I see WR is parallel to ED down here, so I just want to write given and kind of get that out of the way. So now, as we continue on through this proof where they have given us all the statements and we just have to come up with the reasons. So our first statement after the given says that WL is congruent to LE, which that's all fine and dandy as far as I care, because they said L was the midpoint of line WE, so of course both of those are going to be congruent. So I'm going to say, for my reason, is just midpoint theorem. EM? I think EM. All right. So then they tell us WR and ED are parallel, which is lovely. That's good information for us to have and label in our lovely little drawing up here. So let me get my little arrows drawn in there so I have a happy little picture. Now, next thing they say is angle W is congruent to angle E, which in my head that makes sense. So if I kind of extend these out, if I extend these parallel lines out, just so they look a little bit more like something we're used to here, and then I use, let me use green. So if I use WE to cut as a transversal, then I can see angle W and angle E are alternate interior angles. So I feel comfortable saying that those are the same, and I can say alternate interior angles. The next piece they give us is that angle WRL and ELD are congruent, which I'm going to do a little bit of erasing here. So if you want to copy all this down in your notes, maybe pause the video here real quick. So I just want to erase that green line I drew through WLE, because I want to flip my transversal around here. So I'm going to stick with the green line, but I'm going to draw it from R to D this time. So we're using the same parallel lines, and then I'm going to draw a different transversal through there. And once again, if we look, we can see WLR. Ooh, did I want to do that? Hang on. WLR. 222 and ELD. Never mind, I lied. Back. All right, I'm going to leave that initial line in there because I misread what they wanted. So WLR being congruent to ELD, which we can see from our years of working with angles. And by years, I mean mostly this year, but it feels like years because proofs are so enjoyable that time just goes super slow. We can see that we have a pair of intersecting lines, and both those angles are straight across from each other, which are those lovely things that we like to call vertical angles. So I feel 100% confident that those angles are exactly identical. So I'm going to say vertical angles for number 5. And then finally they say triangle WRL is congruent to triangle EDL. So right off the bat, I know in my head we've talked about a couple ways to prove that these are congruent. And now, me personally, if I was you, I would make sure I had all these in my notes in the same place. But I'm just going to write them real quick. So I know we had CPCTC, we had side, we had side, angle, side, and then we had our new ones today, which were ASA and AAS. So angle, side, angle, and angle, side. So now I have to look at my triangles and see which ones we have here. So personally, this is just personal preference, but it's up to you. I like to kind of go up here to the top, and I want to draw this triangle EDL, so that it matches WRL. So I want to make this triangle kind of go like this, and then I'm going to relabel it EDL. And it's totally up to you. It's just me personally, it's easier for me to see this if I relabel it like such. So I'm just going to label all my same thing. So angle E was green, line EL, I put a little red dash on, and I think that's all the stuff we had. So now looking at this, which I'm just going to temporarily kind of erase that from existence. So if I look at these two triangles, I can see I have an angle, I have a side, and then I have an angle. And that angle, or that side, is included between the two angles. So I'm going to say that this triangle is congruent because of angle, side, angle. Now, some people like me like to kind of erase that stuff and set it up so it's perfectly identical. Now you can also do this just leaving it the way it is and counting and saying, okay, I have one angle, I have a side, then I have another angle. Let me get a real thing here. So I have angle, side, angle, and then I have angle, side, angle. You can do it either way. Personally, it's just easier for me to see if I redraw that triangle. So that's why I do my proofs that way. But it's really whatever works better for you. So, continuing on, we have a lovely, lovely paragraph proof, which are just delightful, delightful, lovely creatures. So, I'll read this out loud to you. Essentially, what we are looking for is what our final statement is going to be, and we might have to do a little bit of labeling as we go. So our given says AB is parallel to CD, and then AD is parallel to CB. AD, CB, perfect, delightful. That's already labeled for us. Then they want us to prove that triangle ABD is congruent to triangle CDB. So first things first, they tell us that angle ABD, so I'm going to label that, is congruent to angle CDB, because of alternate interior angles. I agree with that. Perfect. Let's keep it moving. It's labeled now. And then they also tell us angle ADB, so I'm going to grab my blue, ADB, is congruent to CBD because of alternate interior angles as well. Awesome. And then they tell us that BD is the same as DB by reflexive property. So I'm going to label that. Okay. Now comes our final part where we have to do some work. They say triangle ABD is congruent to triangle CDB. Now, once again, I like to redraw these triangles. If you don't, feel free not to. ABD is CDB. So I'm going to just draw it down here for my own personal happiness. And I know it's CDB. And now I'm going to label these same sides from C to D, nothing there. Angle D to B, or CDB. So I have my red angle there, 2, 2, 2, up at the top. Then I have my blue angle over here, and then I have my congruent green side right here. So looking at this, I can see that my reds match up. They're both at the top of each triangle. Then I have my green line, and then I have my blue angle down here in the bottom right corner on each of these. So they line up perfectly. It looks kind of like the wires in a little game of Among Us, but if those line up perfectly like the wires, I know we go red angle, green side, blue angle, so angle side angle. So we're looking at C. Yay. All right, continuing on. So we have angle side. So what this tells us is if we have two angles and any side in the triangle, then those triangles are congruent. So in better math terms, if two angles and the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. And then they write this terrible, terrible flow proof, which maybe it'll help some of you. I left it in there for that purpose. Doesn't help me. But yeah, so that's angle, side. Two angles, non-included side. If they're the same in both triangles, then we're happy to go and keep moving. So, since here's our next example, which is another flow proof, which we love. Just pro tip. Since we just talked about angle, side, I can almost guarantee that's going to be the answer right here, but let's actually look at it. So let's start off. We're given that angle ADB is congruent to angle ACE. So I'm going to label that in the picture. then they also tell us that side EC is the same as side BD, okay? Now, they want us to prove that angle AEC is congruent to angle ABD. So, looking at the stuff they've given us, the first two are our givens here. If we look down at our flow proof. Now, the next thing they tell us is that angle A is the same as angle A, which is perfect because reflexive property demands it to be so. It's the same angle in both situations, so of course it's going to be the same. And now comes the part that we have to do some work on, and that is triangle AEC is congruent to triangle ABD. So once again, as I've said before, I personally like to redraw these triangles, and so I'm going to do that. So I have goes up, goes down, it kind of goes over. So this is going to be my triangle AEC. Now I'm going to relabel those parts. Angle A remains the same. Angle C would be my red congruent. And then side EC is going to be that blue line that's the same. And if I look at this again, and let me get my black outline here. So I'm just going to outline the triangle that we're comparing it to in black, just because these two triangles do overlap, so it is a little bit harder to see. So if we compare these two, I see we have the green up top, which is lovely, and then we have our red to the left, which is also lovely, and then we have our blue line kind of off on the bottom. So I see if we work from top counterclockwise, I see we go angle, angle, side. So angle, angle, side, as previously predicted at the start of this. We're going to skip that. It's a good problem-solving problem, but I don't feel like it's actually that beneficial to us. So I will leave you with this final page. And what this shows is it shows 4 of our methods for proving triangle is congruent. The only one missing here is CPCTC, which I would fill in and make sure that all 5 of these make their way into your notes, because it's going to be very helpful